Alright, so this is the second video on reflections. So the last video had to do with reflections across the y-axis and the x-axis. This one is when you have to reflect across other vertical and horizontal lines besides the axis. So, things like y is equal to 2, x is equal to -3, things like that. But anyways, I'm going to start with something from yesterday because this is something I sort of didn't get into because I wanted to sort of focus on the ordered pairs and what the actual rule was. Because the rule for reflections across the x and the y-axis are pretty easy to work with. However, you can do this completely visually as long as you have it drawn out on a graph, and that's what I wanted to talk about right now. So this is one from the other video. We're going to be reflecting across the y-axis, which means that we are going to reflect across this axis right here. So you can see in green, that's my mirror. So all you have to do is actually, when you have it on the graph, is count how far away things are. So if you'll notice that the C vertex here is 1 unit away from our mirror. So what I'm going to do is count 1 unit away in the opposite direction. So if I count this direction right here, the new C would be right here. B is going to stay exactly where it is because it's actually on the mirror. And then D is, let's see, it's 1, 2, 3 units away from the mirror. So I'm going to go 1, 2, 3 over here. So I'm going to go ahead and put that one there. And as far as drawing the thing, I'd be done at that point. As I discussed in the other two videos, sometimes this is all done in sort of an ordered pair context. So, you might have to come up with the answers, but you can do it pretty easily because I can see where they are. C, for example, is at 1, 2. B has stayed where it was. Down here it's 0, -3. And D is over here at 1, 2, 3. So it's -3, -1. So you do all the same things visually, but I really want to apply this to what we're working on. With the focus of this is, what do you do when you have stuff that looks like this? So this is asking me to reflect this across y is equal to 1. So it's not the x-axis or the y-axis. So how does that work? Well, it actually works exactly like what I just showed you. So the first thing is, our mirror is not the y or the x-axis, as I said. The mirror is this other horizontal line. And one thing that kids will get confused a lot with this is the horizontal vertical thing. So remember, y lines are the ones that run back and forth like this. Okay. So in the last two videos, I talked a lot about rules. I talked a lot about ordered pairs and stuff. If I go ahead and finish this out right now, so this is where it's going to end up if I reflect it like that. And this is sort of what the ordered pairs look like. But one thing I want you to note is that when we did the reflection before, it was really easy. It's like if you had a 3, now it became a -3. It's just the opposite. However, with this, that's not happening. I have a 5, and then I have this -3. So what's the connection between that and the 1? Well, there is one, but it's more complicated and it changes every time. So the truth of the matter is, I probably would not advise trying to come up with a rule for this. I probably would do this the way that I just talked about. The first thing I would do is say, where is this line? So I'd have y is over here. So that's my mirror. And then what you're going to do is you're just going to do what I did before. You're going to say, okay, I'm going to focus on S. S looks like it's 1 unit away. So S is going to be right there. It's 1 unit away the other direction. P lines up in the same spot right here. So what I'm going to do is put that one right there. Q is going to line up along this line right here. So you could see Q is 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4. So that's where Q is going to end up. And then I'm going to have R, which is going to line up on this line right here. So R is 1, 2, 3, 1, 2, 3, 4. And if I connect all that up, I believe that is where the other one was. Make sure. No. I believe it overlaps it. Yeah, so you can see I'm actually in the, I can get rid of that sloppy thing. Oops. But it ends up in the same spot, so you can do it visually. Then if you have to, you can write all these ordered pairs and stuff. So it's the same thing as before. So let's do another example here. Um, this one here. So I'm going to be reflecting this across x equals 2. So x is a vertical line, so that would be right here. So that's my mirror. Let me do it in green, actually. So that's where x is equal to 2 is located. Then what I do is I just sort of go point by point. So W, you could see it's 1, 2 units. So actually all that happens here is it looks like W and X are going to actually change spots because they're both the same distance away. So all that would happen here is this would become X and this would become W. So that kind of saves me some work. The V looks like it is also 2 units away, so it's going to end up here. And the Y is actually on the mirror, so it's going to actually look just like this. And then if you want, you can go through and sort of write down all the ordered pairs for things. But if I had to, which is what I'll do now, one of the instructions a lot of times you'll get is they'll want you to show the change. So what you could do is just like we did before. I can list out, oops, I don't need a dash on it, W, X, Y, and V. And so W was originally at 0, 0. X was originally at 1, 2, 3, 4, 0. Y looks like it was at 2, -4. And V is at, what is that? 1, 2, 3, 0, -3. So, this is what we do in the other videos. I listed this out. I then, of course, could go through, I won't do it all here, but just to kind of give you a point. The new one, you can see like, it switched with X, and I just go through them all like that. And I just kind of write them all down. So you can still do the same thing, even though you're doing this visually. Lastly, the easiest thing is when it's already been done and they're sort of asking you like, well, like what happened? What's the rule for what occurred here? The best way to look at this is any kind of reflection always has a sort of butterfly effect. I always say it looks kind of like a butterfly. And you can see the middle of the butterfly is right here. Make a actually a really big thick line so you can see it. See, that's where it is, and that's a vertical line, so I know it's X, and it's going through 1 right here, so that's it. So you'd say reflect across X equals 1. Okay? That is how you finish out reflections.